Namaskar. Welcome to Sai Economics Point. In today's lecture, we will discuss simplex method of linear programming. Okay. Suppose this is the given problem, that is maximize z equal to 4x1 plus 5x2 subject to x1 plus 4x2 less than equal to 10 and 5x1 plus 3x2 is less than equal to 16 and x1 and x2 is greater than equal to 0. Okay. So here you will use the simplex method to find the optimal solutions of the linear programming problem. Okay. These are the steps, okay, to find the optimal solution, okay, through simplex method. Okay. So first step is we have to write the standard form of the given LPP, in which number one, all constants have less than equal sign where the objective function is of a maximization form, and all constants have greater than equal sign where the objective function is of a minimization form. Okay. So let's check it. So, say in the given problem, check in the given problem, okay, this is a maximization problem, okay, see and check the constants all are in less than equal form, okay, so nothing to do it, okay. So, we can write the standard form here, maximize z equal to 4x1 plus 5x2 and whatever given is we will simply just will write it because it is already in the standard form, so nothing to do, okay. Then next step is transform every inequality constant into an equal constant by adding a slack variable to every constant if the problem is maximization problem, okay. And uh, next is we will write the extended objective function by adding slack variables and will assign a zero cost coefficient in the objective function, okay. So let's check it how to do it. So, by adding the slack variables to the subjective function to remove inequalities, the extended objective functions becomes, say, x1 plus 4x2, you have to add one slack variable, that is s1, so this equal to 10, and second constant, this becomes 5x1 plus 3x2 plus s2, that will add a slack variable and equal to 16, okay. So now the extended objective function becomes z equal to 4x1 plus 5x2. Okay, s1 with 0 coefficient and s2 with 0 coefficient. Okay. Then in the next step is we have to form the equation into a matrix format and formulate the initial basic feasible solution. Okay. So let's check it. So, see here, after adding the slack variables, the subjective function is this and the extended objective function is this. So, if we will form the equation into a matrix format, then this will become 1, 4, 1, 0, because here the coefficient of x1 is 1, coefficient of x2 is 4, and the coefficient of s1 is 1, and s2, this is the here it is absent, so you will put here as 0. And next see, the coefficient of x1 is 5, coefficient of x2 is 3, and s2 is present here, okay, and s1 is absent, so for s2 we will put 1 and for s1 we will put 0, see like that, okay. And multiply by x1, x2, s1 and s2, so this equal to the RHS constants, that is 10 and 16, okay. Now we'll formulate the initial basic feasible solution table, okay. So first we'll take CB. CB represents coefficient of a current basic variable. Here basis means basic variable column, and here we'll take coefficient of x1, coefficient of x2, here we'll take coefficient of s1 and coefficient of s2, and this B represents your constant column, that means right hand side of a constant equation values, okay. This is also your solution values, okay. And this dr is your displacement ratio, okay. it is calculated, okay, in order to find out the pivot row, okay, by ignoring the negative magnitude. Okay, so the formula to find out the displacement ratio is B by PC. That means constant column divided by your pivot column or the key column. Okay, and here bj, see, bj represents what? Bj is your coefficient of, say, this bj coefficient in the objective function. Okay, and zj, what is zj? Zj, say, this is the row of opportunity cost. Okay, and it is a calculated value. Okay, so this is the formula to find out jj. Okay, so how can you find jj? This is the summation of the product of cb into aij. Okay, that means summation of a product of a coefficient of okay, current basic variable and the respective coefficient of that row. Okay, this represents the optimality testing, or it is the net evaluation row, or you can say this is the indicator row. Okay, and it can be calculated in two ways. Okay, so say, how can we calculate? First one we can calculate is the difference between zj minus bj. Okay, or you can write it bj minus zj. Okay, that is s1 and s2. Okay, and here we'll take the coefficient of s1 is 0 and s2 is 0. Initially we have taken the values of the coefficient of s1 is 0 and also s2 equal to 0, so we'll put here. Okay, and say from the matrix format. Okay, so this is the coefficient of x1 and x2, and this is the coefficient of s1 and this is s2, so we have to put this value here. Okay, so x1 is here 1 4, and s value of s1 is 1, here will be 0, and here it is 5, here it is 3, here it is 0 and 1. Okay, so this is b represents your constant column, that is the RHS of a constant equation values, which is the, say, which is your 10 and 16. So we will write here 10 and 16. Okay, so in this row bj represents coefficient in the objective function. Okay, so say this is the coefficient in the objective function, say this is 4 and 5. Okay, so here we'll write 4 5, here we'll write 0, and here we'll write 0. Okay, then next we'll calculate zj. Okay, so how will calculate? So this is the formula. Okay, summation, okay, cb into aij, that is the summation of a product of a coefficient of a current basic variable and a respective coefficient of in that row. Okay, so how can we calculate that? See, z1, that means here, so this is represents here. Here we'll calculate the value of z1. So z1 equal to, say, this is cb1 into this. Okay, this one into this one. Okay, plus this into this, that means 0 into 1 plus 0 into 5. Okay, so this equal to here 0. Okay, and z2 equal to, say, 0 into 4. Okay, plus 0 into 3. Okay, so this equal to again here 0. Okay, the next z3 equal to 0 into 1 plus 0 into 0. So this is equal to 0, and z4 equal to, say, 0 into 0 plus 0 into 1. Okay, so this equal to here again 0. Okay, now calculate the values of delta j. So this equal to, the formula is zj minus bj, so this means 0 minus 4, 0 minus 4 equal to minus 4, 0 minus 5 equal to minus 5, this is your 0 and this is your 0. Okay, So now we'll calculate the largest negative number, okay, to find the pivot column, okay. Because see this delta j, this indicator see represents suboptimality because of a presence of a negative magnitude, okay. So we need improvement because for optimality we need some conditions, okay. See, let's check it, what is the condition for optimality. So the condition is all zj minus bj should be greater than equal to 0, okay. Or if you are calculating bj minus zj, it should be less than equal to 0. So as we are calculating zj minus bj, okay, so all the elements in delta j, it should be greater than equal to 0, okay. So, as the indicator row represents there is suboptimality and we need improvement, for that we have to formulate the BFS 1. Okay, for that we need pivot column or the key column and the pivot row. Okay, so the next question is how to find the pivot column. Okay, so for pivot column, okay, we have to select the largest negative magnitude. Okay, so here the largest negative magnitude is, say, this one, this minus 5, okay. So this is the largest negative number, okay. So this becomes your pivot, so this becomes your pivot column, okay. And next we will find, okay, the pivot row. Okay, so how we'll find it? Okay, the pivot row, the smallest positive number, in this DER, that means displacement ratio, decides the pivot row. Okay, so how can we calculate it? The formula is this one, that is B by pivot column. Okay, so how can you find out? See, so now we will calculate the displacement ratio. Okay, so this is calculated by B by pivot column. Okay, so this equal to 10 by 4, this equal to 2.5, and the next is 16 by 3, equal to 5.3. So to find out the pivot row, we have to find out the smallest positive number in there. So out of this one 2.5, see, this 2.5 is the smallest positive number. So and this decides the pivot row. So this will become your pivot row. That means one, this row becomes your pivot row. Okay. Now we have to find out the key element, that is the pivot element. That means the intersection of a pivot column and pivot row. So this is your pivot row. Okay. So this is the intersection point and this becomes your pivot element. Okay. This becomes your pivot element, or it becomes 4 is becomes your key element. Okay. Now, to formulate BFS 2, okay, to formulate BFS 2, okay, we have to check which one is the entering variable and which one is the existing variable, okay. As we know, this is, suppose this is your row 1 and this is your row 2, and row 1 is your pivot row, okay. So here S1, see, S1, this becomes your existing variable. This is your existing variable, and this row, this what pivot column. That means X2 is your pivot column. This is your entering variable. Okay. So, the purpose of formulating second BFS is to convert the pivot element into 1 and all other elements to 0. Okay. So, let us see how to formulate the BFS 2. Okay. So here in basis x2, see x2 enters and s1 out. Okay, so here we'll write x2 and s2, and as you know the coefficient of x2 this is 5 and the coefficient of s2 it is 0. Okay, and here we'll write coefficient of the objective function, that is x1 it is 4 and it is 5, and for s1 it is 0 and for s2 it is 0. Now we will calculate the row values. Suppose this is row 3 and suppose this is row 4. Okay, so this is the formula to find out the new value. So the new value, that is row 3 equal to old value multiplied by 1 by 4, that is row 1. Okay, so row 1, okay, multiplied by 1 by 4. Okay, so 1 into 1 by 4, this equal to your 1 by 4. Okay, then 4 into 1 by 4, this becomes your 1. Okay, then 1 into 1 by 4, again this becomes your 1 by 4. Okay, then next 0 into 1 by 4. Okay, so this equal to 0. Okay, then here 10 multiplied by 1 by 4. Okay, this equal to your 2.5. Okay, next we'll calculate the values of row 4. Okay, so the formula to find out the new value equal to old value minus 3 times revised pivot row. Okay, so here we will get the revised pivot row value. Okay, so we will find out the row 4, okay, by deducting 3 times revised pivot row from, okay, row 2. Okay, so let's calculate it. So here 5 minus 3 into 1 by 4. Okay, so this becomes your 17 by 4. Okay, then next 3 minus 3 into 1, this becomes your 0. Okay, then next 0 minus 3 into 1 by 4, this becomes your minus 3 by 4. Okay, then next here 1 minus 3 into 0, this becomes your 1. Okay, then the next 16. Okay, 16 minus 3 into 10 by 4. Okay, 16 minus 3 into 10 by 4. Okay, this becomes your 34 by 4. Okay, so this is your new value. Okay, next we will calculate the z values. Okay, so here z1 equal to 5 into 1 by 4 plus 0 into 17 by 4. Okay, so this becomes your 5 by 4. Z2 equal to 5 into 1 plus 0 into 0. So this becomes your 5. Okay, next Z3 equal to 5 into 1 by 4 plus 0 into minus 3 by 4. Okay, so this equal to your 5 by 4. The next is 5 into 0 plus 0 into 1. So this equal to your 0. Then we will calculate the values of a indicator row. Okay, the formula is see, this one minus this one. So 5 by 4 minus 4. Okay, so this equal to your minus 11 by 4. The next is your 5 minus 5 equal to 0. Next 5 by 4 minus 0. Okay, this equal to 5 by 4. So here it is 0. Okay, the negative magnitude in the indicator row shows that there is suboptimality. So we need improvement. Okay, so for that we have to find out the pivot column and the pivot row. Okay, and as you know pivot column. Okay, how to find out the pivot column? The largest negative magnitude, okay, in the indicator row decides the pivot column. Okay, so which one is the largest negative number? So this one, this minus 11 by 4, this is the largest negative number in the indicator row. Okay, so this is your pivot column. Okay, so this is your pivot column. Okay, so this becomes your pivot column. Next we'll calculate the displacement ratio. Okay, so the formula is constant column divided by private column. So this is 2.5 divided by 1 by 4. So this equal to your 10. Then next is 34 by 4 divided by 17 by 4. So this equal to your 2. Now we have to find out which one is the smallest positive number, okay, which decides the pivot row. So this is your smallest positive number, okay, and this is your pivot row, okay. So this is your pivot row, this one is your pivot row, okay. Now the intersection of a pivot row and pivot column, this becomes your key column, okay. So this is your key column, okay. And as you know, okay, the pivot column, okay, decides the entering variable, okay, and the pivot row decides the outgoing variable, because this is the smallest number in this row, okay. So here s2, okay, s2 is your, say, so s2, this is your existing variable or outgoing variable, okay. And x1 is your entering variable or incoming variable, okay, while formulating the next BFS, okay. Now we'll formulate the BFS 3, okay. So in basis we will write, see, s2 is your existing variable, okay. So and x1 is your entering variable, so right here uh, it is x2, and x1 enters here, and the coefficient of x2 is your 5, okay, and the coefficient of x1 is your 4 here, okay. And let this is row 5 and this is your row 6, okay. Then we will calculate the values of row 5 and row 6, okay. As you know, okay, here we have to convert the key element into 1, okay. So for that we have to simply multiply 4 by 17 to the pivot row, okay. So 17 by 4 into 4 by 17, okay. So this becomes your 1, okay. Then 0 into 4 by 17, this becomes 0. Then minus 3 by 4 into 4 by 17, this equal to your minus 3 by 17, okay. Then 1 into 4 by 17, this equal to 4 by 17, okay. Then here 34 by 4 into 4 by 17, okay. So this equal to your 2, okay. So by applying this formula 4 by 17 to the pivot row, that is the new value equal to, okay, old value multiplied by 4 by 17, we will get these values, okay. Now we will calculate the values of row 5, and as we know, we have to convert this element into 0, okay. So for that we have to how to calculate it, we have to deduct 1 by 4 times to the revised pivot row from the old value, okay. So row 5 equal to row 3, okay. So row 3 minus, okay, 1 by 4 times of a revised pivot row, okay. So let's calculate it. Here 1 by 4, so 1 by 4 minus 1 into 1 by 4, okay. So this becomes here 0, okay. So I am repeating this, how to calculate, say, row 3, that means old value minus 1 by 4 times revised pivot row. So this is 1 by 4, okay, minus 1 by 4 into 1, okay. So this becomes here 0. The next is 1 minus 1 by 4 into 0. So this equal to 1. Okay. The next is, okay, 1 by 4 minus 1 by 4, okay, into minus 3 by 17. Okay. So the next is 1 1 by 4 minus 1 by 4 into minus 3 by 17, minus 3 by 17. So this equal to 20 by 28, okay. Then next is 0, Okay, 0 minus, see, 1 by 4 into reverse pivot row. So 1 by 4 into reverse pivot row value is 4 by 17, 4 by 17. Okay, so by simplification we will get this is your minus, okay, minus 4 by 68. Okay, the next is 2.5 or 10 by 4. Okay, 10 by 4, okay, minus 1 by 4 into reverse pivot row. So 1 by 4 into 2. Okay, so this equal to your 2. Okay, so the values of R5 are, okay, say here 0, 1, 20 by 28, minus 4 by 68 and 2. Okay, so we have to just put this value in row 5. Okay, so next we will calculate the values of z. Okay, so this equal to your 5 into 0 plus 4 into 1, so this becomes your 4, and z2 equal to 5 into 1 plus 4 into 0. Okay, so this equal to your 5. The next is 5 into 20 by 28 plus 4 into minus 3 by 17. Okay, after simplification we will get the value is 8.74. Okay, then next is 5 into minus 4 by 68 plus 4 into 4 by 17. So after simplification we will get the value is 11 by 17. Now we will calculate the indicator row, values of the indicator row. Okay, so this is your z minus pj. Okay, so this is 4 minus 4 equal to 0. This is 5 minus 5 equal to 0. This is 8.74 minus 0 equal to 8.74, and this is your 11 by 17 minus 0, this equal to 0. Okay, so the next we will check the optimality test. The indicator row shows that, okay, there is nothing is negative. Okay, so that means optimal solution is possible here. Okay, and as we know, this column represents the solution column, so the values in the solution column represents the optimum value for the basis variable or the structural variable. Okay, now what we'll find, x optimum is 2 and x2 optimum is 2. Now we'll calculate z optimum. So z optimum equal to 4x1 plus 5x2. Okay, so by simply putting the values of x1 and x2, we'll calculate the values of z. So this equal to 4 into 2 plus 5 into 2. So this equal to 8 plus 10, and this equal to 18. So this is your optimum value. Okay. Thanks for watching. Have a nice day.